So let's keep going on these. We're going to do many more problems. And for the first three, we're not going to have to solve it for the square root term. They'll be set up like that. But then we're going to look at more advanced problems where we will actually have to solve for the square root term. But that's the general strategy. Get the square root term by itself, and then you can take a square of each side of the equation. So we will do that here. Let me just rewrite it. And to cancel out the square root, we will square everything. And remember what it means to square anything. If you have 4 squared, that really means you're multiplying this that many times. So 4 times 4. But it's the same with expressions. Since we're squaring this, we're going to multiply this entire expression twice. So let's rewrite that as 2y plus 5 multiplied by itself. We're multiplying this entire expression twice. And keep in mind, one of the most common mistakes that students make is they will square the first term and they will square the second term, but they won't multiply the two expressions together. And basically, you lose some terms when you do that. So make sure not to make that common mistake. You're not distributing this square to each of them. That's not what's happening here. You have to remember what it means to square something, which just means we're going to take whatever the base is and multiply it twice in the case of squaring. And on the right-hand side, the square root and the square will cancel, and we just get 15 minus 2y. And now at this point, we will multiply out these two binomials. So the 2y is going to distribute to the 2y and the 5. And same with the 5. That will distribute to both of these. You can also use the FOIL method. So 2y times 2y would be 4y squared. 2y times 5 would be 10y. And 5 times 2y is also 10y. And then 5 times 5 is 25. Now we have a quadratic equation, which we can solve for by setting one side equal to 0. And then we can either use factoring or we could use the quadratic formula for this. So let's move everything to the left-hand side so that we can keep this coefficient positive. And to do that, we will add 2y on each side. And we can also combine these like terms and then add the 2y to that. And we'll also subtract 15 on each side so that we can essentially set one side equal to 0. So when we do all that, we get 4y squared. So 10y plus 10y is 20y, plus 2 more y would be 22y. And 25 minus 15 would be positive 10. And this is all equal to 0. Now, one thing you should always look for when solving any type of equation is if you can make a cancellation. And notice each of these numbers is an even number. So let's just divide everything by 2. So when we do that, we get 2y squared plus 11y plus 5 equals 0 divided by 2, but that's just 0. And like I mentioned, we could either try to factor this, or we could just use the quadratic formula. And I'll use the quadratic formula here. So in our case, since this is y, we have y is the opposite of b plus or minus square root of b squared minus 4ac all over 2a, where we're looking at a general quadratic. Now we usually see it in terms of x, but this one will be in terms of y. So ay squared plus, by plus c equals 0. And so we can just match up what a, b, and c are, and then plug them into the equation. So we have the opposite of b, so that's the opposite of 11, which is negative 11, plus or minus b squared, so 121, minus 4 times a, which is 2, times c, which is 5. And then we'll divide everything by twice a. So in this case, divide by 4. And at this point, we just need to simplify everything. So let me make a little bit more room here. And we can continue up here. So we have negative 11 plus or minus. We'll have to simplify the square root. We have 121 minus 4 times 2 is 8, times 5 is 40. And then all divided by 4. And from here, we will do that subtraction. So 121 minus 40 will be 81. And the square root of 81 has a whole number answer. That's just 9. So we have minus 11 plus or minus 9 over 4. And now we'll look at our two solutions. So minus 11 plus 9, that's negative 2 over 4. And then we have minus 11 minus 9, which is minus 20 over 4. So those simplify to minus a half and minus 5. So these are our two solutions. But again, just like the first one, we need to check for extraneous solutions. So we're going to plug these back into the original equation and see if it makes sense. So let me rewrite those. We have x is minus a half and minus 5. And so at this point, we're going to check. So we can plug them both in. We get 2, let's do 1/2, or minus 1/2 first. So we get 2 times minus a half plus 5, and we're trying to see, is this equal to the square root of 15 minus 2 times minus a half? And on the left-hand side, this becomes negative 1 plus 5, which is 4. And on the right-hand side, we get the square root of 15 minus this product here, but the 2's would cancel, the negatives would cancel, and you get 15 plus 1, which is 16, and that is true. So we know for sure minus a half is the solution, but let's check minus 5. So I'll make just a little bit more room over here. And when we plug in x is minus 5, we get 2 times minus 5, which is negative 10, and I'll rewrite that in a moment. And this will be equal to the square root of 15 minus 2 times minus 5. And so on the left-hand side, we get minus 10 plus 5, which is negative 5. And you can immediately see that something's wrong, because when we take the square root of something, or when we use this radical notation, we're talking about the principal square root, or the square root that's positive. Technically, the square root of 4, or if we ask ourselves what number multiplied by 4, or multiplied by itself, gives us 4, there are two answers, but when we use this radical notation, we just want the positive answer. So this is positive 2, even though it's also true that minus 2 squared is 4 as well. But when talking using this notation, we're not asking for this. We're asking just for the positive case. So you can see that something's wrong because this has to be positive, but let's continue. This just becomes 15 plus 10, which is 25, and you get minus 5 is 5, but that's obviously not true, which means that we can eliminate negative 5 as the answer. This is what we call an extraneous solution. So it's a solution that we got from solving this that's not actually a solution. And again, we will discuss that in greater detail in a later video, specifically focusing on these extraneous solutions and why they exist. So in the box, we would put minus 1/2 as our answer for y.